In this video, I'm going to explain about index addressing mode. In the previous videos, I've already explained about immediate addressing mode, register addressing mode, direct addressing mode, and indirect addressing mode. Okay, these four addressing modes already we discussed. Okay, so we discussed what immediate addressing mode, which is suitable when we are dealing with what constant, and then we discussed what direct addressing modes. This direct addressing mode we used whenever we are dealing with what some variables as normal variables, and we are discussed indirect addressing mode. This is very much suitable whenever we are dealing with pointer variables. Okay, but these addressing modes are not enough when we are dealing with arrays and lists. Okay, so whenever we are using in our program constants, we go for immediate addressing modes, variables, direct addressing mode, pointer variables, indirect addressing modes. But we go for this index addressing mode whenever we are dealing with the arrays and lists. Okay, we know that. What is the array concept? So array is what collection of similar elements, okay, in a contiguous manner. Okay, let us suppose take this is my one array which contains some 6 elements. Okay, let us take the array name as ARR, and we know that. So assume it is an integer array. So assume the starting address of this array is 2000. Since one integer takes 4 bytes, this will take 4 bytes, and next address is what 2004. Next address is 2008. Next address is 2012, 2016, 2020, like this. And now assume I have stored some values inside this one. Okay, assume I have stored some 9, 7, 4, 12, 10, so 8. Assume these are the numbers I stored. Now, how to get, in order to access the array elements, we know that we have to use the concept of index. Okay, we have to take the concept of index. Let us write the index. So generally the index starts with 0. That this is the index or positions. Okay, now assume this is, if I want to access, for example, this value 12, so then I want how to access in programming language. Say we use the array name, and within the subscript, within the square bracket, I am telling its position 3. If I say ARR of 3 means I will get to 12. If I say ARR of 4 means I will get 10. But index is only for our reference. But in real time, in the memory, there is no index, only the address. So, but we know that always, what is meant by variable? Variables are nothing but the name given to the memory location, right? So, if I say array name, so whatever the array name, if I use the array name, that array name gives us the starting address, always. Okay, whichever the programming language, whichever the subject, always array name gives us the starting address. Now, I know only the starting address. In order to get this 12 from this address, starting address, I need to move this main location. That means from 2000, I need to move 12 bytes. 12 bytes I need to move in order to reach 2012. That means from 2000, I need to move what? 12 bytes in order to reach 2012. So this I will say the what? Base address, also called as what? Starting address, so called base address. That means this is the base, starting address. So in order to get any of the array elements from the starting address, I need to move some locations. For example, in order to take this location, this value, I need to move from here 4 bytes. In order to get this value, I need to move from the starting address, I need to move 8 bytes. In order to get this value from the starting address, I need to move 20 locations. So always, because why we reference this one only, because array name is a starting address, that only we know. Other than that, we don't know anything. So the base address, from the base address, how much we are moving, that with that address, we will call it as offset address. Okay, offset address says that how much you need to move from the starting address or from the base address. This offset address is also called as displacement address. Displacement, that means how much you need to displace from this location. Okay, so offset address, displacement, both are same. So this is what the concept what we are using the arrays. Now, whenever we are using arrays, in order to access any elements, we have to use two address. Which are those? One is starting address, that is called as base address. Another one is offset address. So, I am writing these two in the instruction. So, this base address, generally this base address we are storing in some general purpose register. Any general purpose registers. I will take some RI. That means it may be R0, R1, R2, R3, whichever the registers. Okay. If I store the base address in any one of the general purpose, like R0, R1, R2, and if I write offset address as a constant, then that type of addressing mode is called what? Index addressing mode. Okay. In index addressing mode, we are writing the base address, okay, in the what? In some general purpose register, RI, and see, because why are we using bracket? Because in this register I am storing the address base that we discussed the indirect addressing mode. Whenever we are, so this bracket indicates this register contains the address, not the value. So bracket. Now, so we need to write array means we have to write say offset address, how much you need to move from the starting address. Okay, so that I am selecting as some X locations, some X bytes you have to move. Okay, so this one, this is the general way of writing the index addressing mode. So in why it is called index addressing mode, we are writing this index, okay, in the form of offset address as a constant. Now, effective address of in this one we are writing as effective address is equal to whatever the offset address we are writing X plus whatever this RI is having. Okay, so these two if I add these two, whatever I'll get that one. Suppose for example, my instruction is add. Okay, for example, say 20 R1 comma R2. So the meaning of this instruction is, see, I am having some memory location somewhere. Okay, assume. So this is some location. Okay, this is main memory. Assume this is some, say for example, say 1000 address. So this is say some 5000 address. Now I am having two registers R1 and R2. Now R1 contains what? See, bracket some address. So let us take 1000 is stored in the R1 and R2 contains say some 25. Okay, here see R2 doesn't have a bracket, that means R2 contains value. This is written within the bracket, that means R1 contains address. Now, so what does it mean? So this is indirect. So now add 20 with the address stored in R1. What is stored in R1? 1000. Now you add 20 plus, see this one, 20 plus 1000, how much? 1020. Now this is my 1020. That means you have to move 20 bytes from this address, 20 bytes address. So my another variable, so another operand, say let us say 14. So this 14, now I need to add actually 25 and 14. So this, not to get this 14, I need to move 20 locations from this address. So if I move from 20 locations from this address, so here my actual operand is there. So this is my effective address. That is what the effective address. Okay. So I will add 14 with 25, 39. That will be stored in R2 only. This is what the index addressing mode. Okay. Hope it is clear. Now, there are some slight variation of this index addressing mode. So here what I did, in the index addressing mode, we have written, so here what we stored, here we stored the what? Base address. Here we have stored base address, also called as starting address, okay, or also called as initial address. Now in X I am storing what? Offset address. If you are storing base address in one general purpose register and you are mentioning offset address a constant like this, so then it is index. Now you can ask the question, can we write index, that is the offset address inside the register, and the starting address as a constant? Okay, like the same thing now we can write like this, add 1000 R1, comma R2. Now in this case what happened? In this case, let us take this one. Okay. Now R1 I am having R2, again R2 on 25. Now again I need to add 14. 14, okay, 14 is there, these two I need to add. So R1 I am storing, so in R1 I am storing 20. R1 is storing 20. So it is 1000 here. But effective address, how to get effective address? This plus this one. That's what the effective address. This plus this one. Now R1 contain not the value 20. This is not the 20 value 20. R1 is the address because we are in bracket. So R1 contains 20, that means from 1000 you can move. Okay, so that means again R1 contains 20, so this is 20. That means if you move 1000 location, okay, if you move 1000 location from 20, again come to 1020, again get this one. See, both are same. That means anyone, either the base address or the offset, you write it in one general purpose register, another one as a constant. This is the basic form of the index addressing mode. But there is a slight variation of this. Instead of storing any one in general purpose register, another one as a constant, we can store both in some general purpose register. So now in this case, suppose now I will store Ri and Rj. So both are address because one is offset address, another one is base address. So I am writing both within the brackets. Now here I am storing what? Either I am storing base address in Ri or in Rj and another one offset address. This is not compulsory to store base address only in Ri. You can store offset address. See, here I stored offset address in R register. So like that, here you store offset address. Here you can store what? Base address. R. Here base address, here offset address. So this is called base with index. This type, if you write like this, again, how to get the effective address for this? Again, effective address for this case is what? Effective address is equal to Ri plus Rj. This is the effective address. Okay, if you write like this, then this addressing mode is called as a base with index. So now again, with suppose if now these two are suitable when we are dealing with one-dimensional array. Suppose we are using two-dimensional array. At that time we go for what? Base with index plus offset. That means base with index and offset. That means I am using this one. Along with that, I am using what? One more thing, that is what? See, Ri, here I am storing base address, here I am storing what? Another row address, column address, and offset address I am writing it as a constant again. So this is called base with index. In this case, effective address is calculated as x plus Ri plus Rj. This is what base with index. Okay. Now, these three variations, especially we are dealing with the arrays and lists. Now, in the index addressing mode, we have stored base address in the one of the general purpose register. Instead of storing base address in what? General purpose register, if we use a particular special purpose register called program counter. If I store in program counter, if I store the what? Base address, and as usual offset address if I write in the as a constant x, then that type of addressing is called relative addressing mode. Okay, so in relative addressing mode, base address is stored in what? Base address is stored in program counter only. You should not use any other register. And offset address you specify as a constant. Offset address you are writing as a constant. Then that type of addressing mode is called relative addressing mode. So where it be used? See, this relative addressing mode is used whenever we are using branching statements in our programming language, like if statement or if else statement or for statement, while statement, like that. Whenever we are moving from one place of the program to another place, so that where to me, always we are not moving forward. Sometimes we go back also in the program. Okay, so at that time, whenever we are moving from one location to another location, at that time we go for what? This relative addressing mode. So relative addressing mode we use in the case of branching statement. For example, I written some random level, right? Say some statement. So then I could check some condition while some condition I've checked condition, and within the while statement I do some operations. Okay, let us take only 3 operations I did. I'll assume, for example, I did 3 operations. Now assume this statement starts from the address 1010. So assume each instruction takes 4 bytes. This instruction 1014, this is 1018, this is 1022, this is 1026, this is 1030, 1034, 1038. Now assume when control comes to this statement, with this statement, see, my processor is executing this statement. At that time, program counter contains what? This one. Okay. At that time, program counter contains this one. So assume when my processor is executing this statement, that is this statement it is executing. Now program counter contains a 1042. Okay, program. But in place of it, actually, after executing all the statement of the while loop, control should go what? It should go back to what? Again, the condition should go back. So condition is again go back. So 38 to again is go back to 22. That means actually 38 from actually program code is not 42. From 42, how to go 22? Have to minus 20. That means minus 20 I write in the place of what? Place of offset address, and program counter contains what? 1042. Now if you add these two, minus 20 plus 1042, I will get 1022. That means I am going back here only. Okay, so this is where we are using the relative addressing mode. Okay, so in simple, relative addressing mode we are using whenever we are using some branching statements. Just to tell after this statement whether it has to go back somewhere in the program or it should go after some places, after some statements, okay, to skip some statements, branch, okay, at that time. So how much they have to move? Okay, see, from here it has to move 20 bytes previously, or sometimes it has to move from 30 bytes or whatever ahead. At that time, that will be right in the place of offset address, and program counter content will be written in this place, program counter, okay. This is how relative addressing mode will work. Hope you people understood this concept and which addressing mode is used in which cases, or dealing with what type of variables or what type of situations, that you understood very well. If you have any questions, please write it in the comments. Thank you. Thanks for watching.